Hello guys, welcome to another video from Computerscience channel. In this video, we're gonna solve the problem number 11 from Sipser textbook, and actually this question is about NFAs, and we're gonna prove some feature in NFAs with together, and yes, that's it. Let's solve it together. Okay guys, as you can see here, this is the exercise number 11 from the textbook. It says that we want to prove that every NFA can be converted to an equivalent one that has a single accepted state. Actually, it means that assume that we have an NFA and we call it N. We want to actually construct a new NFA and call it N prime. And in this new NFA, we only have one accepted state, and other states are normal states. But how we can do this? Actually, in Sipser textbook, some question have answered, some selected question have answered in Sipser, and I say that where we can find better answer in Sipser textbook. So I prefer to explain it from Sipser, and this is the answer that you can find in Sipser textbook. It says that assume that we have an NFA called N. We know that we can actually define any NFA with five basic sets. First one is Q, after that is sigma, and then we have transition function, and after that a starter state, and after that our accepted state that we call it F. It says that we have to construct an NFA, call it N prime, with a single accepted state that recognizes the same language as N. Informally, N prime is exactly like N, except it has a epsilon transition from the state corresponding to the accepted state of N to a new accepted state. And we call this new accepted state Q accept. A state Q accept has no emerging transition. More formally, M prime is equal to actually we define our state with a union of Q and Q accept. Our alphabet is the same as N, and after that we have a new transition function that we define it actually in this part here, and our starter state is the same. And in this new actually NFA, we have only one accepted state, and we call it Q accept, where for each Q in actually set of a state and A in our alphabet with actually epsilon here, our transition function is something like that. If A is not equal to epsilon or Q is not in our accepted state, our transition function will remain the same. Actually, it's something like that. Assume that we have NFA like this here. Actually, these two states are our accepted states. So we want to construct a new NFA that has only one new accepted state, and other states are not accepted states. So all we have to do is that from these two accepted states, actually define a new, yes, we will remove our accept symbols like this, and after that we define new epsilon arrows to one new state like this, and this is our final accepted state. So if we are in some state like here, actually in this one, we will act like our first NFA that we have, and we call it N. But if we are here in one of our previous accepted state and our new transition is one epsilon transition, we will act like that we have a new Q accept, and we can go to this state with epsilon transition. And yes, that's it. This is the a new transition function that we have. And final note is that transition of Q accept with any transition, I don't know, for each A in alphabet, union of our alphabet with epsilon, our final answer is actually empty, and we can't go to another state with any transition. And yes, this is the proof that we can use it, and based on this proof we can actually transform any NFA to one new NFA with only one active state, and you can use it in some question, I don't know, for simplifying your NFA or something like that. And yes, that's it. This is the answer for Sipser exercise number 11. I hope you guys enjoyed this video and learned something about NFA and computational things in this video. If you like it, like this video and subscribe to my channel. And if you have any idea or any opinion about my videos, you can leave them in the comment part. I will read all of your comments. And yes, that's it. Have a nice day, guys. Goodbye.